This short video will be covering the topic of arthrokinematics, or if we break this word down, joint movements. As a part of this video, I will introduce the three arthrokinematic movements of spin, roll, and glide or slide. I will then later in the video introduce the concave and convex rule of joint movement and its application in the body to help us apply and understand arthrokinematics at each joint of the body. So firstly, roll. Roll is an arthrokinematic movement, let me start with spin. Spin is an arthrokinematic movement that is important to understand. It only occurs at three joints in the body. Those three joints are pictured here on this slide. They include at the humeral head as it sits in the glenoid fossa, at the humeral head as it sits inside of the acetabulum, and at the humeroradial joint as the concave fovea of the radius contacts the capitulum of the humerus. So spin is very much like a top where you are going to have a longitudinal axis along the length of a bone, and that axis will stay in the same point as the movement occurs. This is an important motion to consider in arthrokinematics, and as you go on in your clinical schooling, this will come into play. As a part of this class, it's not something that we will continue to focus on, but I do want you to know and understand that this movement does occur, the movement of spin does occur, and it's important to account for. The next arthrokinematic movement that I'm going to cover is roll. So roll is the movement in which points at intervals on a moving joint surface contact points at the same interval on the opposing surface. So let me give you an example here. A lot of people can compare this to tire on a pavement or a ball rolling on a floor, where if this ball were to stay in place, as the ball rolled, you would have multiple points along this ball contacting the similar surface of a joint. Let me come over here to this video and give you an example of that here in the shoulder. So as this shoulder moves in flexion, into shoulder flexion, we have multiple points. As the shoulder rolls, we have multiple points of the humerus contacting the same surface of the glenoid fossa. Same thing here in extension. Let me back this up one more time. So this is the concept of roll, arthrokinematic roll inside of a joint. Let me come back here and let me introduce the last topic, and then we'll get into the concave and convex rules and how we can apply these. So the last arthrokinematic movement that I want to introduce here is glide or slide. This is movement in which a single contact point on the moving surface contacts numerous points on the opposing surface. A nice example of glide or slide, in my opinion, visually, is here at the knee. So as the knee moves, let me even back this up just a little bit. As the concave knee moves along the convex femur, you'll have a single point of the concave tibia, which is contacting multiple points of the femur. And this is what is meant by glide or slide. And hopefully visually, we can see that here. So with those three arthrokinematic topics covered, let me jump down and I want to introduce and briefly cover the concave and convex rule of joint movement. So all synovial joints may be classified as either concave or convex. And now let's jump into the roll. So I will say this multiple times over the course of this class, but I want to introduce it here and then I'll say it again and again. The first thing that we're going to cover is the roll rule inside of this synovial joint with our concave and convex rule. Roll always follows the direction of bone movement. I'm going to say that one more time. Roll always follows the direction of bone movement. So I'm going to come back here to our shoulder. I'm going to come back here to the beginning. So in movements that occur in the sagittal plane are considered anterior and posterior movements. Movements in the frontal plane are considered superior and inferior movements. So as we watch this shoulder move and we apply the roll rule here, I'm going to use the terms anterior and posterior. So as this shoulder moves into shoulder flexion, the osteokinematic movement is anterior. So we would say that the roll is anterior. As this shoulder moves into extension in the sagittal plane or down, I would say that that osteokinematic movement is posterior, and therefore I would say that the roll is posterior. Let's do this one more time, or maybe two more times. So let's come right here before it. Let me pause it. There we go. So now we're doing some internal and external rotation at the shoulder. So if I use this greater trochanter of the humerus here as my reference point, as this shoulder moves into internal rotation, I would say that this greater trochanter is moving in an anterior movement. Therefore, I would say the roll is anterior. And then as this greater trochanter moves into external rotation, the bone is moving posterior, so therefore I would say the roll is posterior. So I'm going to come back here to our slide. So once again, roll always follows the direction of bone movement. That's the first thing to know. With the roll established, we can now move into establishing the direction of our glide. So let's come here. So when the concave surface is stationary and the convex surface is moving, the gliding movement in the joint occurs in opposite directions. So this is going to be an example of the shoulder. Let me come back to our trusty shoulder video. We have another one. So inside of this, pause it there, inside of this shoulder, we have a convex bone moving on a concave surface. Let's come back to our slide. When the concave surface is stationary and the convex surface is moving, the gliding movement in the joint occurs in the opposite direction to the roll. So this will be a frontal plane movement of abduction of the shoulder. So the first thing we're going to establish is the roll. So the roll here is going to be superior because the osteokinematic movement of this bone is superior. Therefore, the roll is superior. Coming back to our concave and convex rules, we know that if our convex surface is the moving bone, then the gliding movement of the joint is going to be opposite. So coming back to our shoulder, if the roll is superior, then our concave rule, arthrokinematic rule, states that the glide will occur inferiorly. And then as this shoulder moves into adduction, we will say that the osteokinematic movement is inferior, so therefore the roll is inferior, thus the glide is superior. Now we will cover our convex rule. Our convex, when the convex surface, this is the concave rule. When the convex surface is stationary and the concave surface is the moving bone, the gliding movement in the joint occurs in the same direction as the roll of the bone. I'm going to come back to our knee to demonstrate this. So when the moving bone is concave, like here on this tibial plateau, moving on a concave femoral condyle, then the roll and the glide will occur in the same direction. So as this knee moves posteriorly, because this is a concave bone moving on a convex surface, I would say that the roll is posterior, therefore the glide is also posterior. That is the concave rule of bone movement.